Hello guys, today we're focusing on the chapter 4 corrections, so basically the solutions for the chapter 4 assessment on probability. So let's look at the first one. We're asked to find the probability of getting a club if a card is randomly selected from a deck. So note that for part A, we want the probability of club, and there are 52 cards in a deck, and there are 13 clubs. Alright, if we were to reduce this, which is what you're supposed to do, you'll get 1/4. You can also write this as 25% or 0.25. Now we want the probability of king. In your explanation, make sure that you explain, how many clubs there are, how many suits there are, and so on and so forth. So for this, we have the probability of a king. So there are 4 kings, 1 from each suit. Okay, so club, hearts, diamonds, spades. So we got 4 out of 52, which reduces to 1 out of 13. So for red card, so we want the probability of red, there are only 2 colors, and there are 26 of each color. So 26 out of 52 cards, which is 1/2. Now let's look at number 2. When 2 dice are rolled, find the probability of getting a sum less than 4 or greater than 9. So we want the probability of a sum less than 4 or we want a sum greater than 9. Alright, so this is a union, so we're going to add them together. Okay, so we want the probability of a sum less than 4 plus the probability of a sum greater than 9. In order to do this, we need to make a table. This table has all the possibilities, known as our sample space. So we're going to do our sample space down here. So we're going to make, so we have 6 possibilities for the first die and 6 possibilities for the second die. So we're going to draw a 6x6 table. Let me zoom out a little bit. Okay, so now we're going to do, this is going to be for die 1, and this is going to be for die 2. So for die 1, we have 1 through 6. I'm going to give myself some more room here. Okay, in die 1, or die 2 is still 1 through 6. So we can have a 1 or a 1. We can have a 1 and then a 2 for the second die. We can roll a 1, then a 3, and so on. Roll a 2 first and then a 1, which is a different possibility than a 1 and then a 2. And if you got this problem incorrect, make sure that you draw the entire table out It's part of your corrections. And this will actually help us out with the sum. And in the last row, okay, so we have our sample space. So notice that we have a total of 6 times 6, or 36 possibilities. Alright, so now we're going to go ahead and we're going to circle the ones that give us a sum that is less than 4. So in this case, let me do that in red. So a sum that's less than 4. So that would be like 1 plus 2, that's less than 4. Less than 4, when we add those two numbers together, that gives us 2. That's not less than 4, so we're not going to circle that. This one right here is less than 4. And those are the only possibilities, so that's 3 out of 36 for a sum. Oops. For a sum that is less than 4. So here we have 3 out of 36. Okay, now we're going to do the sum greater than 9. So we're going to go ahead and do that in blue. So greater than 9 would be, for example, 3 and 6. Oh, I'm sorry, not great. That's not greater than 9. That's 9. We want like 10 or something. So like 4 and 6, 5 and 5, 5 and 6, 6 and 5, 6 and 6, 6 and 4, because that's 10, and that should be a 1, 2, 3, 4, 5, 6. There you go. So it looks like we have 6 possibilities for greater than 9. Alright, so let's go over here. So 6 out of 36, then we add them together, 9 out of 36, which is 1 out of 4. Alright, and that should be all the possibilities. And I'm going to go ahead and double check my work, make sure I'm not missing any possibilities. Alright, and that looks good. Alright, so that is our answer, 1/4. Let's look at number 3. The probability that a person owns a car is 0.80. So let's go ahead and label that first. So probability of car is 0.80. The probability that a person owns a boat is 0.30. Alright. The probability that a person owns both a car and a boat is 0.12. Alright, so that means that's both. That means it's going to be intersect, and. Alright, so C and B, which means C and B is equal to 0.12. Now we're going to combine the results here for part A. So for part A, it wants the probability that they own either one, so either boat or car. So I'm going to say car or boat. So since it's an or probability, you're going to add the probabilities together. Here's the formula for that. It's probability of car plus probability of boat minus the probability that of having both of them. Alright, we got to subtract the probability that they have both because we're only looking for either a boat or a car. We're not looking for both, which is why we need to subtract them. Alright, so the probability of car is 0.80 plus the probability of boat is 0.30, and then we got to subtract the people that have both because they don't count in the calculation. All right, so 1.10 minus 0.12 is 0.8. Oops, 0. Let me use the eraser here. Okay, there you go. 0.98. So for part B, we're looking for the probability that a person owns a boat given that they own a car. So that's the symbol for the given. All right, remember that the formula for conditional, this is a conditional probability. So the formula for conditional probability is P of B given A equals P of A intersect B over P of A. So in this case, we're going to be doing the probability that they own both, so B and C, or C and B, same thing as that, okay? So I'm going to rewrite it as C and B, just so that it matches up with what the formula says. So I'm going to do C and B, even though it doesn't matter how you write it, over probability of C. Alright, it's always the second letter. Notice that it's the second letter here. Alright, so now probability of this is 0.12 over the probability of C is 0.80. Okay, so we're going to go ahead and do this on the calculator. So we got 0.12 divided by 0.8, and that gives us 0.15. So we got a 15% chance of this happening. Alright. So that takes care of part B and all of number 3. Now let's move on to number 4. So roughly 1 in 6 students enrolled in higher education took at least one online course last fall. Choose 5 enrolled students at random. Find the probability that at least one took an online course. So it says 1 in 6 took an online course. So the probability that they took a course, we're going to call that C, is 1 in 6. This means that the probability that they did not take a course, I'm going to call that C prime. The probability that they did not take the course. So this is they took a course, they did not take. So it's going to be 5 over 6. So if 1 in 6 took it, that means 5 in 6 did not. Okay, so now we want the probability that at least one took an online course. This means that, okay, so we want the probability that the number of people, we're going to call X is the number of people, the number of students that took the online course. So the probability that that number is greater than or equal to 1, at least 1. This means that if you choose 5 students, you can have 1 student that took it, or 2, or 3, or 4, or 5. Instead of having to do all of these numbers and do the entire calculation, what we can do is we can focus on the probability of just 0. So this is what we're looking for. But this is the complement, this is the opposite of that. And this whole thing is your sample space. And we know that the sample space has to add up to 100% or 1. So that means if I if I find out what 0 is, the probability of 0, and I took away 1, and I took that away from 100% or 1, I should get the red. So that's what I'm going to do here. I'm going to do 100% minus the probability of 0, and that'll give me for 1, 2, 3, or 4, or 5. So 1 minus the probability that x is equal to 0. So in that case, we need to figure out what are the chances that none of those students took the course. Okay, so we got, so let's go ahead and do that real quick. I'm going to do that on the side. So P of 0, that's this guy right here. So that means that if we have 5 students and none of them took it, that means that you have 5 over 6 for the first student. So if you were to choose the first student, the probability that they did not take an online course is 5 over 6. If you were to choose the second student, the probability that they did not choose a course is, they did not take one, is 5 over 6. If you pick the third person, the probability that they did not take a course is 5 over 6, and so on. You can repeat this process. Since you are selecting 5 students, all of them have to not take the course for you to get the probability of 0. That means that this is an AND probability. So this has to be true, and this has to be true, and that has to be true. So when you multiply probabilities for AND, or you multiply the probabilities if you're dealing with AND. So in this case, we have to multiply these guys. So this is 5 over 6 raised to the 5th power. So therefore we can take that and plug it in here. Now we got 1 minus 5 over 6 raised to the 5th power. And that's for 5 students that do not take it. And then, so if we subtract that from 1, that gives us the students that did take it, 1 or 2 or 3 or 4 or 5. Now we're going to go ahead and do the math here. And we're going to plug this on the calculator. Alright, so we have 1 minus 5 divided by 6. Let me put this in parentheses here. 1 minus 5 over 6 raised to the 5th power. Okay, I'm going to double check that number. 5 over 6 raised to the 5th power. Okay, so it looks like 0.598. Okay, so our probability is about 0.598. And that is our solution. Now let's go ahead and look at number 5. So we have 3 cards are being drawn without replacement. Find the probability of getting all queens. So we have 3 cards drawn and we are not replacing it. So we have essentially 3 slots and there are 4 queens only. So the probability of selecting the first queen is 4 out of 52 cards. Now you're not replacing the deck. You're not replacing the cards, so now you have 3 queens left out of 51 cards. Again, you're not replacing it, so now you have 2 queens left out of 50. Alright, so now this is, you're having a queen, so queen, and then another queen, and then another queen. So that means this, you have a queen and a queen and a queen. So you're doing the probability of all of this. So that means you are multiplying these probabilities. Alright, so the probability of queen and queen and queen and queen is going to be equal to, so let's go ahead and multiply these probabilities. Four divided by 52 times 3 divided by 51 times 2 divided by 50. So it looks like you got a small probability there. So, So it looks like 1.81 times 10 to the negative 4. Alright, which that's the same thing as 0.000181. Very small probability of that happening. Alright, now let's look at number 6. So how many ways can 5 men and 7 women be chosen from a class of 10 women, or 10 men and 12 women? Alright, so it's good to note that, yeah, 5 men, 7 women. So if you were to do the 5 men, and you were to choose, if you were to have 10 men and you were to choose 5 men, it does not matter what order you choose the men, and it does not matter what order you choose the women. So this is a combination problem. So this is, so order does not matter. Alright, so combination is used. Alright, so since we're using a combination, that means we have the combination. So look, we're going to go ahead and do the men first. So this is the first slot, and then this is the second slot. So we are doing the men and then the women. So the combination of, so we have 10 men and we are choosing 5 of them. For the women, we have 12 women and we are choosing 7 of them. So by the fundamental theorem of counting, or fundamental counting principle, if we have 2 different ways of doing stuff, we multiply the 2 ways together to get the total. So that gives us 10 combination 5 times 12 combination 7. Alright, so you can do this on the calculator, but I'm going to show you the calculation. So we have 10 factorial over 10 minus 5 factorial times 5 factorial. Now we have the women, so we have 12 factorial over 12 minus 7 factorial times 7 factorial. Alright, so now we got 10 factorial is 10 times 9, and we're going to, before we do that, I'm going to simplify the bottom. So the bottom we have 10 factorial over 5 factorial, and then another 5 factorial. Over here, we have 12 factorial, we have 5 factorial, because 12 minus 7, and then 7 factorial. Alright, so now we got 10 factorial is 10 times 9 times 8, 7 times 6 times 5 factorial. I'm going to stop there because I got a 5 factorial there. And this 5 factorial is 5 times 4 times 3 times 2 times 1. And then I'm going to keep this 5 factorial so that it can cancel with this one. Now I'm going to do the 12 factorial. So we got 12 times 11 times 10 times 9 times 8 times 7 factorial, because I want to keep that so we can cancel. 5 factorial, 5 times 4 times 3 times 2 times 1. Notice that 7 factorials cancel. Alright, so now we're going to go ahead and multiply all of this together. So we're going to multiply the numerator together with the denominator, and we will get our answer. I will show you what I get when I multiply the numerator. So let's go ahead and do that. So I got, let me clear that out first. Okay, so we got 10 times 9 times 8 times 7 times 6 times 12 Now we're going to the 12. So 12 times 11 times 10 times 9 times 8. Okay. I want to make sure I did that correctly because I like to double check my work. I want to make sure I typed it in correctly. Okay, so that was way different than I thought than it was earlier. Okay, so we have 2,874,009,600. All right, I'm going to divide that by the denominator, which is basically 5 factorial twice. All right, the good thing is that this has a factorial key, so I got 5 factorial times 5 factorial. So 14,400. So we're going to take our numbers. So 199,584. All right, and that's how you calculate that. So that's number 6. Number 7. So a new employee has a choice of 5 healthcare plans, 3 retirement plans, and 2 different expense accounts. If a person selects one of each option, how many different options does he or she have? Okay, here let me slide this down so you can see that. Okay, so so this is a classic example of the fundamental counting theorem. So you have essentially three slots, because you have 3 different plans that you want to choose from, and you want to choose one from each. So this is healthcare, this is retirement, and this is expense. All right. So you have 5 different healthcare plans, you have 3 different retirement plans, and 2 different expense accounts. The fundamental counting principle, fundamental counting rule, we'll call it fundamental counting rule, states that we can multiply the 3 different ways of doing stuff, and we get a total. So we get a total of 30 options. All right, that takes care of number 7. Nothing too crazy. All right, number 8. The call letters of a radio station must have 5 letters. The first letter must be either a B, J, or K. How many different station call letters can be used if repetitions are not allowed? So we know we have 5 letters for the call letters for the radio station. So 5 slots. The first letter has to be B, J, or K. This one can be this can be other. All of these can be other. All right, all the other letters. So there are 3 choices for that first letter then. Once we get that, and it says repetitions are not allowed, so there are 26 letters in the alphabet. So when we choose one of them, we're down 1, so that's 25. So we have 25 options. I'm sorry. Let me erase that. Yeah, so the first letter has to be that. So there are 25 options. Let me write that better. There you go. So we have 25 options for the other one. Then we have 24 if we use that second one. For the fourth one, we have 23 now, and then 22. All right, fundamental counting rule states that we multiply all of these together. That's what we're going to do. So it looks like we have 910,800 different ways. Alright, so now we're looking at the extra credit. So royal flush in a card game of poker is the phenomenon in which a player obtains an ace, 10, jack, queen, and king all in the same suit. So we know they have to be in the same suit. What is the probability that if you drew 5 cards, you're going to get a royal flush? So probability of a royal flush. So we know we have a fraction for this. Now, let's go ahead and draw our slots. So we have 5 cards that we're going to select. If we drew those 5 cards, they have to have those cards: ace, 10, jack, queen, and king. So let's assume that, okay, so let's start with ace, right? So ace, 10, jack, queen, and king. Let's assume we have that. So in this case, we have 4 different ways to choose the ace. Alright? So because there are 4 suits and there are 4 aces. Alright? So once we grab that ace, that means now we have one choice for the 10. The reason why we have one choice for the 10 is because once we draw that ace, everything else has to be in that same suit. So if it has to be in that same suit, then that means that if I choose, like, say, an ace of spades, then the 10 has to also be spades. So same suit. Which means that the jack has to also be spades. It can't be a jack of hearts or anything like that. Same thing for the queen, same thing for the king. You have one option for each of those. So then the fundamental counting rule states that we multiply those ways. So we have 4 ways of getting the cards, the 5 cards. So 4 different ways of getting a royal flush. So that's 4. And notice that it doesn't matter what order we do it in. It doesn't matter if we get a 10 first, or a jack, or a queen, or a king. Alright, so order doesn't matter. So that means, since it doesn't matter, we don't count it twice. We don't switch it and just because we get a 10 first and a jack, it's still going to stay 4 ways. Now, let's look at the denominator. So the denominator, since order doesn't matter, this is a combination, okay? So this is a combination. So we're looking at combination of 52 cards taken 5 at a time. Because we are taking 5 cards, and there are 52 cards in the deck. So how many different ways of getting 5 cards? Alright, so now we're going to go ahead and do this out. So let's go ahead and calculate C, 52, choose 5. So that's 52 factorial over 52 minus 5 factorial times 5 factorial. So 52 factorial is 52, 51 times 50 times 49 times 48 times 47 factorial. The reason I stop at 47 is because 52 minus 5 is 47. And it cancels out. And then this is 5 times 4 times 3 times 2 times 1. So now we're going to go ahead and do that out. Okay, that divided by parentheses 5 times 4 times 3 times 2 times 1. Close, enter. So 2,598,916 ways. Okay, let me write that down here. Alright, and we're going to call it, that's how many hands you can get. So how many hands of 5 cards. But only 4 can be a royal flush. So I'm going to go ahead and reduce that, and I get 1 in 649,740 chance. Alright, and I'm going to do that as a decimal. Oops. So that gives me 1.54 times 10 to the negative 6, which is really small, 0.50154. Very slim chance of that happening. Alright guys, that's going to do it. So that's the entire assessment, and that's the extra credit. I hope this helped you. Make sure you do your test corrections and explanations, and I will see you guys later.